In this video, I'll be discussing the difference between your critical path method and your critical chain project management method. I'll start off by providing some background on the critical path method and then the critical chain project management. Then I'll be providing an example and key steps for your critical path method, and then the example and key steps for your critical chain project management. Now, your critical chain project management is also referred to as your theory of constraint, or the theory of constraint project management, or the theory of constraint multi-project management, the Goldratt critical chain project management, or your critical chain scheduling. Now let's start off with our background. Now, your critical path method and your critical chain project management are both project management techniques that is used to schedule and manage tasks, but they have different approaches and priorities. So our critical path method focuses on your task dependencies and determines your longest sequence of dependent tasks. So that's the shortest possible project duration, which is also referred to as our critical path. It identifies critical tasks that must be completed on time to avoid your project delay. So it focuses on managing your critical tasks on our project. It typically does not consider resource constraints. It uses your float or slack to show how much a non-critical task can be delayed before affecting our project deadline. And the goal is shortest time based on your task dependencies. Now, our critical chain project management, on the other hand, is built on your critical path, but it adds resource constraints like your availability of workers, machines, and material. It focuses on managing project buffers rather than task-by-task deadlines. It uses resource leveling, meaning tasks may be delayed to prevent resource overloading, and you can also go to my description box below to watch videos on resource leveling. It adds buffers to absorb variations and uncertainties rather than allowing float or slack for individual tasks, and the goal is the shortest time considering resource availability. Now, your critical chain project management comes from the theory of constraint, which was developed by Dr. Goldratt in the late 80s and early 90s. So let's have look at an example of your critical path method. First step is to identify all your project tasks or activities. Then to determine your task dependencies, that are finish to start, start to start, finish to finish, and start to finish relationships. So in this example, you can see that task A has got a finish to start relationship with task B, C, D, and E. Task B and C has got a finish to start relationship with task G. Task D and E has got a finish to start relationship with task F. And then task F has a finish to start relationship with task G. And we've also got a start and finish milestone. Now, we also need to estimate our task durations. As you can see, task A has got 1 to 3 days. The duration is 3 days. Task B is 7, C is 6, D is 4, E is 3, F is 4, and G is 3 days. Then we create our project network diagram. Now, this can be done with software like Microsoft Project, Primavera, or Project Libre. You can also draw a network diagram and then do a forward pass to establish your early start and early finish. Then do a backward pass to establish your late start and late finish. And then also establish your project duration and float. And you can also go to the description box below to watch some videos on the forward pass and backward pass. So the project duration is 14 days. We can identify our critical path, which is the longest path through a project. So our critical path for this example is task A, D, F, and G. We can also calculate the float or slack for the non-critical tasks, starting off with task B. It's 1 day before it will have impact on your critical path. Task C has a float of 2 days, and task E has a float of 1 day. And lastly, we need to monitor and update the critical path throughout our project lifecycle. Now let's have a look at an example of our critical chain project management. Also very similar, starting off with identifying all our project tasks, determine your task dependencies, but then important on your task durations. We need to make sure to avoid overestimating task durations, and we need to cut excess safety time that's built into tasks. Overestimation is very common in our critical path method, and the tendency of people is to add safety time into tasks when estimating task durations. So your task duration, we need to eliminate our Parkinson's law, which says that work expands to fill the available time. So let's have a look at our example. So in task A, we've got a safety time of 2 days. So we've established that. So we can change the duration of task A to 1 day. Task B, we removed safety time of 1 to 3 days. So it becomes 4 days. The same with C, we removed 1 day of safety time. Becomes 5 days. D, removed 1 day of safety time, becomes 3. E becomes 2. F becomes 2, we removed 2 days. And then lastly, G, we removed 1 day of safety time, so it becomes 2 days, the duration. So we removed the safety time that was built into our project, and now we reschedule. And our project duration is now reduced from 14 days to 8 days. Now the next step is to add resources to our tasks and identify if there's any resource constraints. So Mike is added to task A. Task B, we've got Emma working on task B, John on task C, Mike on task D, Charlotte on task E, John on task F, and Emma on task G. And we've identified that there's a resource constraint on task C and F. So John is working on task C and F during day 5 and day 6. So we need to remove that resource constraint. So if we remove that, the project duration now changes from 8 days to 10 days. And we've now created our critical chain, which is task A, C, F, and G. So that's our critical chain. Now the next step is to add our buffers. First of all, our project buffer. Now the project buffer is 50% of the safety margin of each task on the critical chain that aggregates into the project buffer. So let's look at our example. So for task A, in our previous slide, we removed a safety time of 2 days. That was removed. Task C, we removed 1 day of safety time. Task F, we removed 2 days. And then task G, we removed 1 day. So it's 2 plus 1 plus 2 plus 1. It's 6 days. And our project buffer is 50% of the safety time. So 6 divided by 2. So our project buffer in our example is 3 days. Now let's have a look at our feeder buffer. Now the feeder buffer is a buffer that is added where your non-critical path merges with your critical chain. Starting off with task B, that's connected to task G, which is on our critical chain. So the buffer is 1 to 3 days. Task D, the buffer is 2 days because it's connected to task F. And then task E, the buffer is 3 days, 1 to 3. It's connected to task F, which is also part of our critical chain. And then lastly, our resource buffer, that's a buffer that is added where scarce resources are needed for tasks. And then the last step is we need to monitor progress and manage our buffer. So instead of tracking individual tasks, your critical chain project manager monitors your buffers. So that's your project buffer as well as your feeder buffer and resource buffer. If this video was helpful, give me a thumbs up, or you can subscribe to my channel for more project management related videos.